Okay, good morning, everyone. I am Shimita Pal. I am a senior principal analyst in the distributed resource planning team at PGE, currently leading the DER forecasting area and supporting the distribution system planning. I may seem to be a new face to some of you. That is because I have been at PGE for about 7 months now. And before that, I was working at Pacific Northwest National Laboratory for 7.5 years as a senior research engineer, leading and contributing several research, development, and demonstration projects there, which included focus on transformation of the distribution system. So I'm very happy to present to you about DER inputs into the IRP CEP update today. So this is going to be an overview of the potential adoption and impacts of distributed energy resources, or DERs, in support of PGE's Integrated Resource Plan, or IRP, and ongoing distribution system plan, or DSP. The DER forecasting work was undertaken in collaboration with CADEO and Resilient Edge. So at any point, if you feel that I'm going too slow or too fast, please feel free to let me know. I will try to answer all your questions to the best of my ability. But having been here for just 7 months, I imagine you may have amazing questions that I may not have thought about before. So if I'm unsure of any answer, I'll beg your pardon, figure out the information, and provide those during the DSP office hours that Shadia mentioned. So on this slide, you see the two main discussion topics that I'll cover today. So first, I will provide an overview of the DER forecasting needs and approach. This will help us brush up our knowledge for those who have been attending these sessions, or to level set the background who have not heard about this topic very much before. Then I'm going to go through the different DER forecasting results across the different scenarios that we have run. These will be used for updating our IRP. So moving to the next slide. So let's do some level setting first. Why do we need to know forecasts of DER? DER forecasts are needed for planning, optimizing, and maximizing the benefits for our customers, our grid, and our overall community. And when I say DER today, I'm talking about resources in the categories of transportation electrification, demand response, flex load, distributed solar PV, distributed storage, and building electrification. And you may be thinking, who needs these forecasts? Well, there are multiple internal stakeholders here at PG itself. So these include our corporate load forecasting, integrated resource planning team, as well as distribution planning team. There are other teams who need it too, but these are the main stakeholders who need it. Typically in a year, we would need to configure the forecasting model and provide it all the updated data that it needs and perform the run to get updated DER forecasts at least once a year for figuring out what level of investments may be needed and what kind of distribution system plans need to be developed. But in the years when you're working on our big plans like the IRP or DSP, we may perform one or two more additional runs and to get more updated forecasts for the purpose of including in these plans. Now, the inputs and the outputs of these DER forecasts have a vintage date. If you see a vintage date of August 2024 on some of the later slides, it essentially means the run has been performed in August 2024. Each run also uses various types of input data, and those inputs may have their own individual vintage dates as well. Now, why do we need it again? So some of these DER resources like building electrification may increase the load, and some like solar may provide distributed generation and therefore decrease the net load. We need to estimate what level of these DERs we expect to see in the system in the future years to be well prepared to balance the net load with large size generating resources in the bulk system, which traditionally deliver energy through the transmission system. And the IRP, it strategically plans how we will meet the future energy needs while balancing cost, reliability, and environmental impacts. Now let's move on to the next slide. So a number of factors influence adoption in our analysis. Therefore, we don't run just one scenario, we run 3 different scenarios. So ref or reference scenario represents our most likely adoption scenario. It is generally an extension of past trends in technology prices and adoption. Low DR adoption scenario is a more pessimistic adoption scenario where we decrease program incentives, increase technology costs, and therefore simulate lower and or slower long-term adoption rates. High adoption scenario, on the other hand, is a more optimistic adoption scenario where we boost measured adoption, which leads to maybe quicker or higher short and or long-term adoption. IRP2 has 3 scenarios. It's called reference need, high need, and low need. These scenarios reflect the level of generating resources that may be needed. So if adoption of a DER decreases net load, like solar PV, then low adoption of it will need to increase need of bulk generation resources. So it will be included in IRP's high need scenario. While high adoption of solar will be important for figuring out IRP's low need scenario. And the vice versa situation happens for EVs, which inherently increase load. So overall, using these 3 scenarios, we get the entire range of resource needs over the future years. The different scenarios also account for the state policies, apart from what I mentioned, the actual adoption data available, price influences in the future, and future technology costs. Not all of the identified adoption measures are cost effective, but we include all of these cost effective measures as well as the non-cost effective measures to see which ones will be picked up by the IRP. Next slide, please. So now, without wasting any more time, let's talk about the DR forecasting methodology. So next slide, please. Okay, so for DR forecasting, we use a tool named AdopDER for estimating all of these outputs. The CADEO team worked closely with PGE to develop AdopDER. It is a tool that performs site-level modeling and simulation for estimating locational hourly load impacts from co-adoption of more than 50 DERs. The framework integrates bottom-up forecasts to provide hourly load and measure shifts down to the site level for each scenario and year over the forecasting horizon. In our case, the forecasting horizon here has been 20 years. The tool also provides anticipated costs and benefits for programmatic measures and estimated cost effectiveness ratios using the total resource cost test. So here on the bottom in the flowchart, you see the sequential workflow within the tool that ingests variety of large data sets to be able to do the granular estimation. AdopDER starts with the individual site as the unit of analysis and models its feasibility and adoption decisions over time. It considers outside system factors as well, like weather, rates, costs, and product availability. So we begin with segmenting the market, which involves breakdown of customers into residential, say single family or multifamily, commercial and industrial categories, and ingest data for modeling their current energy needs and usage. Then we proceed to feed the model the DER measured inputs. These are basically different types of usage of variety of DER products that have the potential to alter the baseline load. For example, one DER measure may be ductless heat pump, where customer may adopt a heat pump system that heats or cools a space through an indoor unit. There are more than 50 different measures in our model, and we show high-level categories of those measures in the next slide. But here, let me complete the workflow. So after the DER measure inputs, once we know the existing customer, the equipment, and measures, we move over to stock turnover. Stock turnover refers to the rate at which DER assets such as solar panels, batteries, and other energy technologies are replaced or upgraded over a specified period. This accounts for site level feasibility for each technology over time. For example, for residential charging, we may need parking availability or breaker availability. So once we understand the life cycle and adoption rates of these technologies or measures, then it yields us a potential model. This is basically the potential for deploying these various DER technologies over our forecasting horizon. Then we have the economic screening or adoption, where we determine at a system level which programs of DER measures are cost effective based on a set of cost and benefit assumptions. And putting all of these together, we are able to determine at system level, feeder level, and even site level how adoption and load impacts vary over time at hourly granularity level. So moving to the next slide, we can see the categories of these measures. These are put in 8 categories here.
Yeah. Shimita, sorry to cut you off.
Yes.
I think
No,
you have a hand
sure.
up. Nick,
Yes.
you have take the mic and ask your question. Thank you for your question.
Hey, Shamita, thank you so much for walking through all of this.
Hi, Nick.
I think I have a simple question. I recognize that a lot of the machinations in these steps are theoretical, you know, the potential modeling, stock turnover, right? These are extrapolations that are done. I think my question is, I'll use myself as an example. I have a plug-in hybrid vehicle that, and the charger is part of PGE's EV charging program. If theoretically, would you be able to look at AdopDER? So I'm trying to distinguish what level of theoretical application there is and where the concrete basis is. And so I guess my question is, theoretically, if a person such as yourself knew and understood, could you put in my site ID and understand, oh, it's a house of such and single family house, it's got a charger, and thus the adoption propensity at this house would be X or Y or Z. Is there, or is that too concrete, or is it all a little bit more theoretical at an basis than like real customer site IDs? Does that question make sense? I hope.
Yep. Yes. No, that's a great question. So it looks very theoretical, and yes, we have a theoretical basis to it, but we use a lot of practical data and training of that data to incorporate all the practicalities. So for your example, say we get DMV data. So I won't say the data is perfect, but to a very good extent, we are able to figure out which sites have EVs, whether they are plug-in hybrid or they are fully electric vehicles. We also know which sites have ICE vehicles. So for all of these vehicles, we have some sense from the VINs, how old or new it is. So if it's really old, going towards that time where it would probably be retired, then we look at the propensity model, whether that customer will go to PHEV or EV. For your case, we might already, if the data is good, which is in most cases, then we would be able to figure out you already have a PHEV and putting together the customer data, we will also be able to figure out how you are using this PHEV. So yeah, we have all the data from different sources, from different internal stakeholders, as well as external surveys combined to figure out how we could make the results as practical and real world as possible.
Okay, thanks, Shamita.
Thank you for the question. So, okay, going to this slide, we have modeled this adoption in 8 high-level categories. From left, you will see for solar and storage, it looks at behind-the-meter solar and battery energy storage, including applications of microgrids for critical facilities. In the next 3 columns, we look at transportation electrification, here market and programmatic adoption of electric vehicles, and accompanying charging infrastructure across all sectors and vehicles are modeled. We have the basic electric vehicles themselves, which are complemented by the basic EVSE technologies. And then there are the charging types, which may be smart or not smart. And then there is residential building electrification, which looks at market adoption of electric water heaters, HVAC, thermostat controls, and even induction cooking technologies to see if any measure can change the electric efficiency or even lead to switch over from one fuel system to electric. Then we have the commercial and industrial demand response, which includes commercial smart thermostat, irrigation, all of those. And lastly, on the rightmost end of the slide, you will see the demand response and flexible loads, which account for programmatic adoption of pricing measures, which include peak time rebates and time of use rates. So now moving to the next slide, here we will talk about what do we include as part of the DER forecasts. So basically, we are determining the hourly load impacts of each measure that is applicable for a site over the forecasting horizon for each of these 3 scenarios, ref, low, and high. There are 3 critical pieces of data here: capacity in megawatt of adoption of each measure, energy impacts in megawatt hours due to the implementation of those measures, and timing of those energy impacts. It is important to note that there are 2 types of DER programs. There are some which are passive, which means they are non-dispatchable from utilities end, like standalone solar. And there may be active ones which are dispatchable resources, like direct load control, thermostats for controlling cooling or heating. So moving to the next slide, we will now look at the DER forecast from the latest run of AdopDER that was done in August of 2024. So very recent, you will see high-level results of ref, low, and high over the next 20 years broken down for solar, EV, BE, and DER. So, but before going there, I wanted to take a pause. That is a lot I went through. I wanted to make sure I address any questions that may have come up so far. Any questions? Okay, if not, then we can move to the next slide. Okay, so first we start with solar. So basically in these slides, I have given the high level discussions of what we see or what are the drivers behind these estimates that you will see, and you might see a figure showing the megawatt average. So you see MWA there on the y-axis, and you see the years in the x-axis. You will see the years run from 2024, which is the baseline year, till 2044, till which the forecasting is done. So for solar, we have employed bottom-up forecasting. We have calibrated our data to include all PG customer installation information that is available to us from interconnection data. And we have on top of that all, so that sets up the baseline. And for the future, we have included NREL's market share information. We have also enhanced the model using the translation of capacity from from capacity to megawatt hour using EPRI's PVLib tool. So you can see in the figure, in the ref case, we have up to 100 average megawatt of solar, and in the high case, it can go up even higher. Next slide. So in the electric vehicles or transportation electrification category, we have modeled all kinds of vehicles. So light duty, medium duty, and heavy duty. For light duty vehicles, we have used market shares provided by EPRI. And those are different. There are different measured adoption curves from EPRI for each of the three scenarios. So ref, low, and high. These are formulated based on the EV purchase price incentives, relative price of electricity versus gasoline, state policies that are favorable to transportation electrification, battery costs, vehicle capability, and model availability. Some of these factors may increase adoption rate, some of these may slow adoption rate, and those different information has been plugged in the different scenarios to get the different forecasts. For medium and heavy duty vehicles, we have used multi-round expert panel or Delphi approach data from Brattle Group. And then these are the vehicle market shares, but in case of transportation electrification, another important data are the load shapes. We have used NREL's EVI ProLight tool to get the load shapes, and we have compared those with available data within PG to make sure those are in line. So moving to the next slide. Yes, I see your hand is raised. Cole?
Hi, yeah, I just had a question about the purchase price incentives that you're
Sure.
including. Is that just forecasting potential price incentives, or is that taking into account like changes in manufacturing to take use of the IRA? Like how in depth are those incentives and some of those inputs being analyzed, and kind of what, like, are those getting their own scenarios themselves and then that influencing the actual scenarios?
So there are two things, and both have been taken care of here. So one is price of vehicles that we may think price of vehicles may decrease over time because batteries may become cheaper, or some other technology part may become cheaper, or it may not decrease that much. And though that has an influence on the adoption rate, as well as what you said, like federal incentives, state incentives. Those also really can motivate customers to buy EVs or not because of the presence of those incentives. So both of those have been taken care of in the scenarios. So for high adoption scenario, we might put more incentives and cheaper prices over time. For low adoption scenario, we might put higher prices of cars themselves and lower incentives to see the whole range that's possible over the future. Emily?
Hi, this question isn't exactly specific to this slide, but I know that PGE has goals as far as decarbonization. Is there any relationship between these scenarios that you're showing? Like, does the reference relate to the goals? Is the high one what the goals are? How do they relate?
That's a great question. So definitely we put very high focus on the goals. We are always looking at the goals and making sure all of that information is incorporated in our modeling and estimates. So I'll just give an example. There is advanced clean trucks rule. So there are some goals associated with that, and we do take that into account when we plug in the adoption curves over the years with the intention and the target of achieving that goal. So that's just an example, but we do give importance to the goals. And Jason, please feel free to add.
Yeah, so Emily, I think you may have been asking a question about PGE's overall goals with regard to decarbonization. So those goals around 2030 and 2040 are to be met regardless of the amount of load on our system or where that load comes from. So there isn't a decarbonization goal that we have that's specific and particular to transportation electrification that we're looking to advance. It's our decarb goals have to do with the number of kilowatts served and how clean those kilowatts are over that period of time. Does that help?
Yeah, that does. Thank you.
Welcome.
Thank you, Jason. Okay, any other questions? Then we can move to the next slide. Oh, yeah, okay. Sorry, I confused you, Shadia. So I just wanted to add that you can look at the this slide and see the curve. So we see lower ramp in the adoption in the short term, which is similar to what we are seeing currently. But we expect it to pick up over in the future years, and therefore at the end we have about 700 average megawatt of DE load. We have covered all segments, light, medium, heavy duty vehicles, like I said, and we have also modeled plug-in hybrids and battery electric vehicles separately. Yeah, so now we can move to the next slide. So here you will see the building electrification impacts. So for building electrification, we have used market shares from NREL's electrification future study. We have derived from that data, and we have also followed up the information with PG's own 2019 decarbonization study. And on the right, you will see the building electrification load. So for the reference case, you will see around 2044, there is about 350 average megawatt hour extra need that would be added due to this electrification. Next slide, please. And then there's demand response. So there, in case of demand response, we have programmatic adoption, which is modeled and simulated, but we also have market adoption in the tool. We look at cost effectiveness, and it is determined by the total resource cost test. It uses the avoided costs for primary benefit streams and different types of program costs, and even dispatch patterns from historical data are used for making it more practical. We phase the functionalities in over time, and the tool is also able to provide levelized dollar per megawatt costs, which are rolled into the IRP update to study possible electric system needs for both cost-effective and non-cost-effective DR. So like I've said before, we do look at, IRP does look at cost-effective resources, but it also adds some of the non-cost-effective resources to see if those will be picked up by the model. Next slide, please. So here on the left, we have shown the DR flex load cost-effective numbers for the summer season. And on the right, we have shown the cost-effective winter resources, all in megawatt. As you can see, the demand response would help in countering some of the additional loads that will come up through transportation electrification and building electrification. And with good participation, we could have by 2044 up to 400 average megawatt of demand response flex load that can help. And in winter, up to 300, more than 300 average megawatt of DR flex load, all of which are cost effective. Next slide, please. So this is my last slide. Again, reiterating some of the points. We have investigated 3 scenarios, ref, low, and high. These account for state policies, incentives, market shares, actual adoption data that we have available, price influences, and even future technology costs. Not all of the identified potentials are cost effective, but we do take into account the non-cost effective ones to see if they add any benefits to the portfolio. And we have assessed and provided as well as presented the results for all of the different measures adoption in the next 20 years. Overall, if we compare with 2023 IRP update, then we will see the TE load growth has decreased in the short term, especially because of what we are observing in our current data. There has been an observed slowdowns, especially in the medium and heavy duty EV categories. BE has slowed down in the short term, but ramps up over the forecasting horizon farther out. And in the longer term, it is slightly higher than what we had in 2023 IRP, but the levels at which we see these numbers are in the same level. They are not very much different. So that's all from me today. Happy to answer any other questions that you may have. Looks like none. Shadia?
Let's give people one minute to think.
Okay.
These are pretty dense.
It is.
You did a great job.
Thank you.
Hi there, this is Peter with the OPUC. I have a question on the building electrification forecasts, and I'm curious if like or how rather the steady state today is trued up with field data, like energy trust incentives for heat pumps or PGE's own marketing that resulted in leads to heat pump clients. Is some of that data in there too to kind of give us the baseline?
Yes, it is. So there are different ways we have tried to make the model as realistic as possible. So through different surveys, we have information for different customers on what kind of heating, cooling, cooking equipment they may have, mostly heating and cooling. So for the customers that we have the information, we can directly use it. These may be multiple surveys. For the others, we use those data as the sample, and we use the stochastically, we figure out which other customer for which we may not have all those detailed data will get which kind of heating cooling, whether it's gasoline, whether it's electric, whether they have already heat pumps, all of those information. So that's setting the baseline. For customer, we know their rate descriptions and the proportion of we also know the incentives cost, which we put in our model. And then there's another way we have looked at the future. Those were the baseline. In the future, for the NREL electrification future study, they had information on the sales of different kind of equipment relevant for building electrification. So we could use that information along with the market shares that we got from NREL to get a more realistic view of how the trend is now and what the trend will look like in the future. So those are some high-level ways that I can share how we have incorporated real-world data and made those estimates more realistic.
That's great. Thank you very much.
Any other questions before we move to our next presentation? Shamita, it seems like we're good to go. You were very thorough. For folks, we're going to reiterate, we will have office hours in 2 weeks. So if there's any further questions that might come later, please join us at the lunch hour. I will be sending an email with the link for you to be able to participate. Thank you so much, Shamita.
Thank you, everyone. And yeah, let me know if you have any questions during the office hours.
Our next presenter is Jason Solmy-Klotz, and he will be sharing with us new development opportunity that we're exploring. Jason, take the floor.
Okay, thank you, Shadia. Can everybody hear me? Assuming so.
Yes, we can hear you.
Okay. Thank you, Shadia. Thank you, Shamita, for that presentation. Thank you, everybody, for being here today. I wanted to share with you some work that's been going on behind the scenes with the U.S. Department of Energy Office of Energy since about May, and it has to do with the AdopDER model, which Shamita just went over with you at a pretty high level. This is a very complex model. This is not a tabletop model. This model is very big. It runs on servers. It takes hours to run. There's a lot of data that moves through it. And we recognize, myself being a former regulator, that there is an analytical imbalance around the ability to use data to inform positions. And so we had a discussion about that at the Rocky Mountain Institute in April. Can we go to the next slide, please? Why don't we back up for one slide? I'll go over the agenda. We want to talk about our work with the U.S. Department of Energy. We want to discuss with you about why we feel that there is a need for a public interface to the AdopDER model, and then how we would approach this particular project. And we're also really interested in hearing whether or not the group here and our stakeholders feel as though this would be a good use of dollars and a good use of our energies here at Portland General Electric, and yours as well, in building a public interface for AdopDER so that you can actually utilize the model and the resources, the tools that we've created. So if we could go to the next slide, please. So I attended a conference. It was a working session over 3 days with the Rocky Mountain Institute in April. There were many entities, utilities, nonprofit organizations, for-profit organizations in attendance. And the work group that I was part of was discussing distribution system planning. We had a gentleman from Resilient Edge who was there with us, who helped develop the AdopDER model. And we were breaking out into smaller groups and discussing, well, what are some of the challenges that distribution system planning faces and how can we address them? And one of them was this imbalance over analytical abilities, and that particularly the utilities have the need to create these models so that they are more accurate, but there's also a need to provide transparency to these models about how they operate, and that's part of what we discussed and showed in the last section. But there's also an interest, we believe, among stakeholders to have some ability to use these models themselves, or these tools. And so we discussed that with Rocky Mountain Institute and several other stakeholders at that working session. And one of the participants was Joe Palladino from the U.S. Department of Energy, Office of Energy, who was very interested in seeing this work developed and wants to know through the funding of this activity whether or not something like this is helpful to our processes in distribution system planning, and whether or not those lessons learned and those tools can be applied elsewhere in the nation. So this would be a first for the country, and it would be a collaboration among PGE, stakeholders, ratepayers, and the commission. Can we go to the next slide, please? So what's the objective here is to create a public interface of the AdopDER model to enable stakeholders to develop and assess planning scenarios, which means being able to develop your own scenarios using the AdopDER model. The model would be housed outside of Portland General Electric for security purposes, data sharing purposes, so that you would be able to have access to the model at any time that you desire, and the ability to run those scenarios at any time that you like. There would be the development of a graphical user interface so that it's easier for you to run the model. Right now, we do not have a graphical user interface. For the AdopDER model, it is code driven right now, and you have to know that code language in order to query AdopDER and create scenarios. Go to the next slide, please. So we'd like to do through this particular project is be able to share with you, adoption, DER adoption information, system forecast, load forecast information by scenarios, for you to present, granular information around the scenarios that you would like to develop, assess cost effectiveness of the scenarios that you are developing, assess our own proposed and preferred scenarios against what you're seeing in your runs and utilization of the AdopDER tool, and give you an opportunity to influence the planning processes of the distribution system plan and some of the investments that Portland General would make on behalf of customers within the distribution system plan or with our distributed energy resource programs. What we're looking to do is share information with you, allow you to have access to information, and utilize that information to be more influential, but also better understand our work and context, especially when using a complex tool like this. Go to the next slide, please. So this work will come in phases, and our stakeholders and our regulators will need to be involved in each and every one of these stages, because we want to create a tool that's useful for everyone, that meets your expectations, and that is easy to use. So with our first phase, we want to gather input from our stakeholders and develop the functional requirements that you're calling out. So what is it that interests you? What are the functionalities that you feel you need? And then we can assess how to create that interface that best meets those requirements that you're setting out through phase one. This project will have roughly 4 phases. It will take a couple of years to develop. This is, like I said, is a very big and complex model, and creating a public interface and being able to develop the functionality that you want and or need will take some time. So within phase 2, we would develop a functional mock-up. On the front end, that's the interaction that stakeholders have. We want to get your feedback to that mock-up on the front end, and then we would develop the back end, which is the computational piece of the public-facing adopter. And then on phase 4, we would be developing a full-fledged web application that contains all the features that were identified as part of phase 1, and then reviewed and enhanced through phases 2 and 3. We have, if we go to the next slide, please. We have secured some funding and also a commitment over those several years from the Office of Energy, Joe Palladino at the U.S. Department of Energy. They have committed for this first round about $450,000 of funding. Portland General Electric will have to commit some additional funds to make this happen. Some of those funds will come from my own budget, my own O&M budget for this particular team. And we may, over the course of the next couple of years, may need to ask for additional funds through likely the multi-year plan process in order to complete the project. When we have better information on the budget information for phases 2, 3, and 4, we'll be sharing those with you well ahead of time so that you understand what the budget requests are, how we're using our dollars, where those dollars are spent, and under what timeline. And each phase will be independently funded. So we would like you to engage early with us. This is why we've opened up this discussion now. We intend to have a series of collaborative workshops so that we can start building the requirements for a public interface and how the particular tool is shaped. We'd like you to share with us your expectations around what you would like from a tool like this. And this is a real commitment to transparency and around this particular model. I know that during the transportation electrification plan in 2023 that we were developing, the commission staff had asked for access to the AdopDER model and found it to be very complex, very comprehensive, but difficult to work with because there isn't an easy interface. And so this particular project would create an easier interface for stakeholders to use this particular tool and to help address the sort of black box feeling that we hear from our stakeholders around some of our modeling tools, and help. My hope is that having a tool like this actually helps us as the utility and stakeholders and regulators come together and better understand the complexities of what is going on here around forecasting and utilization of these resources and how we put together our distribution system plan. So with that, I'm here and open for questions if anybody has any. I'd also love to hear from the group if this sounds like the right pathway. Is this something that people would be interested in having developed? Is this something that people are interested in participating to develop?
Jason, we have Jenny Hall on our chat. She wrote, would this interface give stakeholders visibility and the ability to inform assumptions and data inputs that are built into the model, or only allow interactions with the output of the model?
That's a very good question. And I think that's a criteria that we're going to take back and write down. If that is an expectation, then that is an expectation we should strive to meet. We know that the AdopDER model still requires some upgrades to be even better or more granular. And so we will, we share that information about those updates with you. We can certainly share those updates as part of this process. And we can, yes, you'll have the outputs through this particular interaction. And I believe we have seen other utilities, like we sat down with Avista a couple weeks ago, where they share their input information. So I think it's certainly possible that we can figure out how to share input information through this process. Yes, Bob.
Hey, Jason. Thanks. Super interesting. I was curious if there's anything publicly available that's kind of a step in this direction. Maybe not as, obviously not as complex and thoroughly thought through, but I know, for example, Puget Sound Energy has posted priority electric lines for their DERs. I was wondering if you guys have taken any steps in that direction that's similar to that. Yeah, thanks.
We do have a DER map available on the DSP site. We do, through this process, identify where on our system we do have needs and how we address those needs. We gave a presentation about that a couple of meetings ago, and there'll be some additional information in the DSP about that. I'm unfamiliar with what PSE is doing, so I'm not sure I can commit to that until I see it. I'm sorry, Bob.
Sure. Thanks.
Does anybody have other questions about this? I know this was a relatively high level.
Yeah, thanks. Sorry, Sarah Hall with OPUC. I think that you may have discussed your highest level goals for this, but it probably would be helpful for me to hear you describe again just kind of what your intended, I think you talked about the problem statement around transparency and certainly reflecting some of the staff feedback, but just what your highest level goals again are for the effort. It sounds like a very inclusive and transparent process you've got here, but okay, thanks. Yeah, just taking me back to your objectives would be helpful.
Yeah, I mean, it is to share a forecasting tool with our stakeholders and the commission staff, and create a tool that's easy to use, easy to interface with. Like I said, right now the AdopDER model is not particularly easy to use. It requires an understanding of the Python code. It requires an understanding of data analysis and some of the unique abilities of modelers and forecasters within the energy industry. So what we want to do is just create an ability for you and other stakeholders to be able to query AdopDER and create scenarios particular to your interests.
Yeah, so what would the relationship then be to a back-end side? So where, in terms of governance, are there delineations between the data sets that the company will not disclose, or how do you conceptualize it in terms of as compared to what the AdopDER is today? So there's some, there's just a tremendous amount of data that's hard to transfer or make public.
Yes.
Just from both the proprietary nature of the tool, but also the data size and the dynamics of the changing data. How is this replicative of that, or how does it interface with like the structure of the tool as today?
So yes, there's some things that will have to be reduced in some manner. And the reason I say that is because we have a full distribution system map as within AdopDER and is connected to our distribution system planning activities. It also carries meter information, and it queries sensitive customer information in that respect around usage. So that information cannot be shared. It wouldn't be in whole transferred over to the public facing version of AdopDER, and we will have to work on how that information is collected, reduced, anonymized, and shared into that model so that it can be secure, but also still useful, relevant, and queryable. So I think you may also be asking a very detailed question about, well, how much of what information will be shared, and how much of that do I have transparency to? And I think that needs to be part of the stakeholder conversation and the build requirements that we are all collectively developing around this interface.
Okay, thanks, Jason. And when is your launch for that? What is your proposed date for that launch?
So I would like to start working on this this year, probably the last quarter of the year. We'll be working with Lisa Schwartz over at Lawrence Berkeley National Lab. That's the recipient of the US DOE dollars, and that's who we will be working with to manage the dollars associated with this activity, and the oversight, the US DOE oversight of this activity will run through Lisa. So you guys all know Lisa. She used to be head of our Oregon Department of Energy and used to be a member of the commission staff. And I know that she works with the Oregon Commission staff pretty regularly on a host of items, including the distribution system planning process. So I owe her a scope of work in the next couple of weeks around the expenditures of the $450,000 for that phase one. We need to detail that out for her and then also share that with you. We intend to, if there's real interest in doing this, we intend to give that detail through the multi-year plan.
Thanks.
Welcome. Any other questions? Okay, I'm excited about this particular project. I think there's a lot of opportunity here for us to set some best practices around data sharing and access. And my hope is that we can successfully execute on this together and demonstrate to the rest of the country that this type of transparency and utilization of these models with stakeholders is a positive. So we will submit some additional information as part of an appendix within the multi-year plan that we intend to file in mid-October. So you'll see some additional detail, and we'll be working with the U.S. Department of Energy and Lawrence Berkeley National Lab around this round of funding and subsequent rounds of funding. We are still, I should be transparent with regard to the commitment from US DOE is to continue to fund this activity, assuming the right administration is in place to continue the funding and the activity after this next election.
Well, thank you, Jason.
Yeah.
As As I mentioned on our previous presentation, we will have the slide deck and the video recording in your inboxes and upload it to our website within a week for you to go over again. And if you have further questions or want to discuss about this specific topic more, bring your thoughts. You're welcome to join us on office hours in 2 weeks on September 26th. Thank you, Jason. We will go to our next presenter, Fatima Colorado, our distribution system planning manager, will be joining us to talk more about the collaboration between the transmission planning and the distribution system planning team. Fatima, are you in the room? There you are.
Yes, I'm here.
Take the mic.
All right.
And thank you.
Thank you, Shadia. So my name is Fatima Colorado, and I'm the distribution planning manager here at PGE. So I'll be talking about how the distribution planning team works together with the transmission planning team to make sure that we provide safe and reliable power to all of our customers. So we're going to be discussing, I'm going to give a very brief overview of how the transmission and distribution planning teams work together. And with that, I'm going to talk about, how transmission planning, their processes, and how distribution planning also has the processes to make sure that we have projects that are looking at the whole system in a holistic way. So here is a background of a one-way power flow. So you can see here we have our generation. Then we are transmitting that energy from the generation facilities with transmission lines to our distribution substations. And with that, we're distributing that energy using our distribution lines into our customer homes. So what we're talking about here is, you can see in the picture, there's a circle, a red circle. That's the, we see the distribution substations, that's the square, and then we see our transmission lines. So we're going to be focusing in the coordination that happens between both teams and how we produce projects and infrastructure, really, to make sure that we can serve our homes. So we're going to be talking from a bottom-up approach. And what do I mean by that? So we have our individual homes, our manufacturing facilities, our subdivisions, our commercial buildings. Those are, we have different demand grows that those customers are requesting more energy usage in our system. So when I say bottom up, I mean the customer needs more load that we are distributing with our tap lines through our distribution feeders that connect to our substations. And then those substations are being energized or connecting through our transmission lines. So just as a background, we know from previous presentations that we build our system for peak demand. We want to make sure that whenever it's the hottest or the coldest day in Oregon, or not in Oregon, but in our territory, that we can provide safe and reliable power to our customers. When those customers increase demand for electricity, we study, and when I say we, distribution planning and transmission planning, we study the system to make sure that the system holds up with that added energy usage. If for some reason we determine that we need to build more infrastructure, then we produce a study that determines what are the distribution infrastructure that is needed, but also our transmission infrastructure that's needed to make sure that we can provide continuity from our electric grid. Any questions? All right. Just as a point to make sure, as a takeaway from this picture and this slide, in order for us to bring a new substation, we would have to bring the generation into that substation. And how do we do that? We actually need to install new transmission lines to energize that new big equipment that we call substation. Next slide. So here's our transmission concentric circles. And this is an easy way for us to understand how PGE territory works in the overall transmission system that connects to multiple states. So we can see that the smallest concentric circle, which is the blue circle, the one that it shows a number 1, that's our PGE system. So this is the last mile transmission to make sure that we serve the load to our customers. Our number 2 circle, or the yellow circle, is the interface that BPA and PGE has. So in order for us, if we in PG&E system are seeing an increase of demand, then we would have to work in coordination with BPA to make sure that we bring that capacity into our territory. And then the largest circle, which is the gray circle, that's original interconnections. So imagine you're seeing a lot of lines connected to each other to make sure that we can tap into outside resources from our territory. So make sure that we bring, more efficient ways of bringing that energy into our system. Any questions with this circle, or with the circles, really? All right, so we're going to be focusing really in our number 1. That's our PGE's territory. Next slide. So here's an overview of how the two systems work together. So we can see, and I'm going to focus on the DSP first. We see the load being connected into our distribution system and also transmission system. And we know that loads now is not a one-way flow, but a two-way flow. So we can actually flex that load. But what does that really mean? It means that we are the loads, you can actually flex them, which they'll see an impact on the distribution level, but ultimately on the transmission system. And also the transmission system, we have large generation interconnections. There are also, besides having regular generating facilities, we also have interconnections, like it could be customer interconnections into our transmission system. So, that's the difference between the DSP and the IRP. And here we are, on the left, you see the same graph that we saw before. So we are going to be focusing on the relationship between our distribution system and the transmission system, how we make sure that we take into account not only the distribution lines, but also making sure that we can bring the generation with our transmission lines into the new facilities or the new infrastructures to make sure that we give reliable power to all of our customers during those peak days. Any questions? All right. So here's a very simple way of giving you a transmission planning overview. So we're guided by NERC TPL 0015, which is a planning standard that ensures reliability of the bulk electric system under different conditions. What do we mean by different conditions? It's whenever we see a contingency, and a contingency is when we lose one element of that transmission line. We want to make sure that if we lose one element of the transmission system, the system overall doesn't see the effect of that missing equipment or missing element of the transmission grid. So in order for us to study and make sure that we comply with that standard, we look at different loading conditions. And how do we look at them? We look at a near-term 2-year and a 5-year planning cycle. And we also study them on a long-term planning cycle, which is our 10-year studies. Once we have identified that there is a transmission need, then we propose corrective actions, which are our projects. And then to make sure that whenever we see those near-term and long-term, including our DER forecast and load forecast, that we can provide reliable power to our customers. And then to mitigate those violations of that standard when we study our near-term and long-term studies. And then because we're part of BPA transmission system, we also have to do a regional planning coordination to make sure that whatever projects we have in our system, we work with BPA to have a holistic way of looking at the whole transmission system. Next slide. So how are the two teams work together? So we use our corporate load forecasting, and that is, in essence, a forecast of how much energy we're going to be using in the next years, and that depends on economic growth of the whole territory, and then we also, by having that, I would say, upper forecast of what that energy usage is going to be in the near and long-term future, we add all of our load requests. And what do I mean by a load request? Remember that picture that, we have subdivisions, we have homes coming online, we have new facilities, new manufacturing facilities, new companies coming into our territory. So we aggregate all of those customers' requests, we aggregate them in a list so we can provide a full list of what that growth is looking at the next future years. Once we have that list aggregated, and they come at different times when the customers are requesting the load, we need to allocate those customer requests to where in the transmission those customers are going to be connected. So they're going to be connected at the distribution level, but they all go back to the transmission lines. So once we have all of this information aggregated, we do run a yearly update between distribution, where are those customers adding those loads, to transmission planning to see where those added loads are going to be affecting our transmission lines. So we have the load request, we map it to the distribution feeders, we aggregate all of those loads into the transmission nodes, and then we reconcile that information to make sure that it matches our energy forecast for the next, for our short-term and our long-term planning cycles. So here is how distribution planning handles load request. So we have two ways. We have the yearly planning process where we aggregate and we share that information with transmission planning, but we also have a spot load request handling process. And this comes whenever the customer is ready to add the load. They inform us, and then we study them in a separate way, just that specific spot load being added to a distribution feeders. So we receive the request from the customer, we study for any distribution impacts, and if needed, we see if we have capacity, we inform that to our transmission team, and they decide if it impacts or it needs an upgrade into the transmission system. And then we give back the results to our customers to ensure that they are aware of what the timeline for our upgrades, our distribution and our transmission upgrades, so we can work together to make sure that we're meeting the customer timeline. So as loads they proceed to connect, we mark them, we follow that load, and we mark them as confirmed. The customer needs to, understand their cost impacts. They also need to understand the timelines. So once the customer has vetted all of that information that it's given by our studies, then they need to confirm if they want to move forward or not. If they want to move forward, then we mark them as confirmed, and we keep them. We keep a tab on them to make sure that once we do our yearly planning process, we say these customer requests are confirmed, so we're going to move them forward into our planning process. So once we have those customer requests confirms, we plan for system upgrades, and they're being tracked in our planning models. Yeah, next slide. So this is a more comprehensive look of what our spot load request process looks like. First, we get the load request from our customers. It could be a new customer, an existing customer that is expanding their site. And then what we give them to them, we give them different, we study different options, and we study with all different options of that need, we give them a timeline or we study a timeline when we're going to be providing those options and when we can energize those options to serve the customer load. So we do it with an initial assessment. So distribution planning conducts a system study, and we determine where in our distribution grid the customer will be connecting their load or their facility. So once we have that information, then we can share that with the transmission planning team, so they can see where in the transmission system network it's going to be connected, that load. Once we have, we understand where in the distribution system the load is going to be connected, but also where on the transmission system is going to be connected, that load, then we can develop a solution. Both teams develop the substation, the transmission, and the distribution upgrades if it's needed. Once we have all of that information and we run our models, then we understand what the scope is, and by understanding the scope, we can give a timeline. So our second assessment, we share that information with the customer. The customer decides, yes, this looks okay. Let's go ahead and study it a little bit more. So we go into our second assessment. So we continue to refine those options. At that point, we ensure that all of our major equipment, they usually have long lead time items, and that's related to our supply chain issues and concerns that we have. So we make sure that those are ID'd, we understand the timeline, and we identify what is the cost estimate for those upgrades, and we can build a more refined conceptual schedule. So we share that information with the customer. We share our conceptual scope, our estimates, and our schedule. And those are in the conceptual space still. We haven't done any, design or any scope, like true scoping. This is still very high level. Next slide. So once we're done with the spot load additions requests that they come every single month, once we have confirmed those customer load additions, we can aggregate what that list of customers' requests look like. So we have in that section, in that list, we have committed customers, we have preliminary customers, we have customers that, once they heard the timeline, maybe is not it doesn't match what their company wants to achieve. So they are no longer committed. But we still keep them in that list. But this list that we're going to be sharing to transmission planning, it's only the committed customers, because those are the customers that they want to move forward with with the project. So once we have a list of committed customers, we have a two distinction between those customers. We have customers that they're energized and customers that they're partially energized. And what I mean by energized and partially energized, in our definition of energized in this case, is that the customer has matured their energy usage. What it means is they're connected and they're not going to be requesting or adding any additional load. And partially energized means the customer is energized, but they haven't achieved their fully load or their fully potential, or what the customer is envisioning for their plan, for their subdivision, or for whatever type of customer that we're talking about. So once we assigned a customer that is partially energized, we continue to verify the loads to make sure that their expansion matches with our project, to make sure if they are, for example, they have a lot of issues with construction and expanding their site, then we don't have the same timeline commitment that we had at the beginning when we conceptualized the project. And that is to make sure that we're not energizing projects way in advance from what the customer is needing to have usage of those buildings. So we verify the construction times, and once the customer has matured their energy usage, they move back into an energized category. And it could be that it's examples of this. It could be that it's a manufacturing facility, that they have different phases where the customer wants to energize different buildings, for example, or different plants, or different lines of production. Or it could be a little bit more simple, where we have a subdivision, and one subdivision can be multiple phases, where the house developer is not building the whole subdivision because they don't know what the economy is going to look like once those homes are going to be ready. So they build them by phases. So we make sure that we verify, their construction times to make sure that we can match as best as we can whenever that customer is going to use that load. And going back to that example of the phases, it could be of the subdivision. It could be the phase one, it's sold out, and we need to hurry up, and they need to hurry up to construct phase two, but we also need to hurry up to construct our infrastructure too, our distribution and if needed, our transmission infrastructure. But it could be the other way around, where they finish phase one and our economy doesn't look that good, where they might say, hey, we're not ready to build phase two. So we have to have that constant conversation with our customers to make sure that we understand their needs. And we call them KCMs, and they're key customer managers, and it could be the project manager too, talking to the customers, so we really understand what is their needs and what is their newest timeline, so we can make sure that we have accurate forecasts for our system. Any questions? Next slide. So here's how it looks, our yearly planning process. So distribution planning aggregates all of the new load additions, confirmed load additions, with the respective load ramps by feeder and substations. And we aggregate them by time too, because we want to make sure that we match that information is used in our forecast. Then transmission planning and the DR forecast team include all of these new confirmed additions for their respective studies. So for example, if I know of a load addition that is happening in a subdivision, then we want to make sure that our forecast team can say, yes, I agree, this is already in our forecast. So it's not going to be forecasting something that it's not there yet, but it's going to happen sooner because we have that information from the customer. And then transmission planning uses that information to run their system-wide studies. And these are their short-term planning and the long-term planning. Their 2 and their 10-year planning with the guidance of the NERC standard. The next NERC standard, it's a federal standard that ensures reliability into our transmission system. So next are new load additions, or that list that we aggregate every year, is used to refine the DER forecast. And that's what I said when I meant we want to inform that the customer has informed us of a new load addition happening in our territory. So then our forecasting is not going to double count it and say, we also are seeing this in the future because it's true. But if we don't share that information that the customer has shared with us, with our forecasting team, we might run into the issue of saying there's going to be load happening because we know it, but also the forecast team is saying the same thing. So we want to avoid double counting loads in the same area. And then our last step is that we use distribution and transmission planning. Once we have that DER forecast refined, we use it to forecast future investment planning opportunities. So we make sure that by using the refined forecast is that we are matching what our customer usage is going to be in the future. Next slide. So here's our distribution study process. We study our system at various loading conditions, the same as transmission. We study them during our peak days, or we want to make sure that we can match while our system can hold what the customers are using on the hottest and the coldest day in our territory. So we have different horizons. We have near term and long term. So near term, it's our 2 and 5 year studies, and then we also want to make sure that we can cover for our 10-year forecast for our planning horizon. Once we identify that we are going to be exceeding our thresholds for capacity in the distribution system, we have a list of green needs or corrective actions. Once we have those corrective actions or projects, then we develop with the assistance of transmission planning to make sure that we look at the system holistically, so we can produce projects. And once we have our projects vetted, we have the options, we have cost benefit analysis performed, we have timelines, we have estimates, then we include that as part of our capital portfolio process. Next slide. So this is an overview of how we are integrating both the transmission and the distribution planning studies into one. We do that so we have coordination between the 2 different departments to make sure that we are ensuring a resilient infrastructure capable of meeting our future needs, that we are forecasting with our forecasting tool to make sure that we can meet those energy demands in the future. Any questions?
Fatima, looks like you were super clear.
Or unclear.
Well, if anyone has questions that might come later, as I mentioned, we will be happy to have you at office hours on September 26th into Thursdays during the lunch hour. I will be sending the meeting on Zoom so that you can join us. It's an informal, organic fashion to talk more about the topics we discussed today. Thank you, Fatima.
Thank you. Thank you, everyone.
Well, it seems like we will be able to gift you back 19 minutes to your day that probably most of us that are at too many meetings seems like every day would appreciate. So let me walk you through our closing remarks. We have, oh my God, there you go. I didn't update that properly. We have the next IRP CEP meeting coming up October 2nd. We will have our office hours in 2 weeks on September 26th during the lunch hour. We have our CBIAG meeting on Wednesday, September 25th. And our next distribution system workshop will be on October 24th. I really appreciate everyone for supporting this effort of being together with our stakeholders, hearing your thoughts. I think the more we learn about these processes and the more we understand what are the components you don't understand, the more transparency we can have in these plans and include your voices in the making of the plans. So thank you so much for participating and have a great day. We'll see you soon. Happy end of the summer.
Thanks, everybody.